Hello guys and welcome back to your physics session. Today inshallah we are going to learn and study what is the meaning of thermal energy. First of all guys, I need you to scan the QR code, watch the videos and return back. By using the simulation guys, we are going to study what is the meaning of motion of particles and how do particles move and act in their motion. By releasing some particles of a gas in a closed container, we are able to notice that some particles are moved very fast and others move slowly. So they differ in speed and also differ in kinetic energy. This difference in speed and kinetic energy make the temperature. And the total kinetic energy of these particles is defined as thermal energy. So if you would like to define the thermal energy is the total kinetic energy of all particles. If you would like to define the temperature, we'll define it as the average kinetic energy of particles. While the heat energy is the amount of thermal energy or kinetic energy transferred between particles from one object to another object. Now we are able to know the difference between thermal energy, heat energy, and temperature. Thermal energy is the sum of the particle energy that form the matter. The type of energy here is kinetic energy. The type of energy is kinetic energy. While the temperature is a measure of average kinetic energy of the particles in the object. While heat is the transfer of thermal energy, which occurs spontaneously from a hotter object to a cooler one. We have different scales, guys, to measure temperature of the object. The SI unit of temperature is Kelvin. So when you measure, temperature must be provided in Kelvin. We have different scales, Kelvin, Fahrenheit, and Celsius. To change from Celsius to Fahrenheit, we have to multiply the Celsius by 9/5, then add 32. To change from Fahrenheit to Celsius, we have to subtract firstly subtract 32, then multiply by 5/9. Notice the difference between the two rules, guys. Here I'm changing from Celsius to Fahrenheit. So firstly, I multiply by 9/5, then add 32. If you are going to change from Fahrenheit to Celsius, you have firstly to subtract 32, then multiply the answer by 5/9. To change between Celsius and Kelvin, from Celsius to Kelvin, you will add 273. From Kelvin to Celsius, you have to subtract negative 273. Subtract 270. What is the meaning of thermal equilibrium, guys? Equilibrium is the state which has equality. So, if I'm going to find equilibrium between two objects, that means they have the same state. They have the same description. If I'm talking about thermal, as we said, so I'm describing the motion of particles. The hot object has more kinetic energy, while the cold object has less kinetic energy. So we have two objects, one at the right and one at the left. The one which is represented by blue color is cold, has low temperature. The one which is represented by red color has the higher temperature. After touching each other, the kinetic energy of particles will be transferred from the hot object to the cold object. To have by the end the same kinetic energy. Having the same kinetic energy can be described as the thermal equilibrium. So the thermal equilibrium is the condition in which two or more objects in thermal contact with each other exchange no net heat energy because they have reached the same temperature, they have reached the same average kinetic energy. Types of heat transfer, guys. We have three types of heat transfer. The first one is conduction. The second one is convection. The third one is radiation. What is the meaning of conduction, guys? Conduction is the method of transferring heat energy by two objects when they touch each other. It always happens for solids, transferring energy between solids, as solid particles are unable to move. They just vibrate in their place. So they have to do something called conduction to make transferring of energy. Conduction is the transferring of energy when two objects touch each other. But convection is for fluids, like gas and liquid. The motion of particles for gas and liquid are not limited. The particles are free to move. So they can move up and down to make something like a circulation. If I have a container, and below this container is a source of heat, and this container contains water with different particles, the particles at the bottom of the container are going to be heated faster. So it's going to move upward. And the cold particles, which were at the top, going to move downward to make something called convection current. So the convection current depends on the movement of particles from one place to another place to distribute the heat energy. So the convection is the transferring of heat energy between liquid and gases, fluids, as a result of particles motion. So convection process depends on particles motion. Well done. What is the meaning of radiation, guys? Radiation is the transferring of energy in the shape of waves without existence of the medium or as the existence of medium. So radiation is the transfer of energy by electromagnetic waves, like the heat of sun reaches the earth without existence of particles, without existence of medium. So the only method to transfer this heat is radiation. Radiation doesn't depend on the presence of matter. Doesn't depend on, but it can travel through matter. If you would like to find the amount of heat transfer, Q is the amount of heat transferred between two objects. M is the object mass. C, something called specific heat, is the amount of heat required to raise up the temperature of 1 kilogram of substance by 1 degree. So, would like to find the amount of heat transferred to the object, I have to multiply the mass of this object by the specific heat and by the change in the temperature. As we said, the definition of a specific heat is the amount of heat required to increase the mass of an object of 1 kilogram. So I have to multiply the mass by specific heat, as the specific heat is calculated for each 1 kilogram. And also, it's calculated for 1 degree temperature. So I have to multiply by the amount of degrees which the substance raised to. So by the end, the amount of heat is mcTF minus Ti, final temperature minus initial temperature. Guys, I have to know that if Q by the end became negative, that means the energy has left the object because the final temperature is less than the initial one. So Q will be negative. If it has positive value, that means the object has absorbed thermal energy, as TF minus TI will be positive, T final greater than T initial. Let's define specific heat. Specific heat, as we said, the amount of energy must be added to material to raise temperature of unit mass, which is mean 1 kilogram, by 1 degree temperature. Specific heat represented by C and measured in joule per kilogram dot Kelvin. If I'd like to find the C, specific heat from this rule, C will be Q divided by M delta T. Q, amount of heat measured in joule per mass in kilogram. The SI unit for temperature is Kelvin. So we got the measuring unit. And as we said, the amount of heat required to change the temperature of the object depends on its mass and the change in temperature, as we said before. Let's solve some questions, guys. What is the 25 degrees in Kelvin? It will be 298 Kelvin. Which type of heat transfer occurs through direct contact of particles? Well done, conduction. Heat energy flows from high temperature to low temperature. Thermal equilibrium is achieved when all of them. Objects have the same temperature, objects stop exchanging energy, no net heat flow occurs. A block of 3 kilograms, so he provided the mass of a metal with a specific heat of, here is C, is heated from 25 up to 75. So the object absorbed amount of heat and its temperature raised up. The rule is saying that the amount of heat is equal to mc delta T. Q is equal to mass, kilogram. You have to sure about the unit. So it's 3 multiplied by C, which is 400. And the temperature change is 75 minus 25. Notice that, guys, we have temperature in Celsius, but we said that the temperature must be in, well done, Kelvin. So, do we have to change the temperature in Kelvin? I will advise you, I will give you advice. Return back to the specific heat unit and find what is the temperature unit. If the temperature unit is provided by Celsius, so work with Celsius, because you have to convert both of them, temperature and specific heat. Well done. Focus. What is the unit provided for temperature and what is the unit provided for a specific heat? If they are matched, go ahead and solve your problem. If not, try to convert the easy one, which is temperature. So the answer will be, by the end, 60,000. Moving to a new part, guys. Heat and change in a state of matter. What is the change of heat for a certain matter? If I have a piece of ice, by adding heat to this piece of ice, it will melt. The melting process itself is the process of changing solid into liquid. By changing solid into liquid, as solid still exists, there is no raise in temperature. There is no raise in temperature, as all of the heat amount added to the piece of ice is used in changing ice into liquid. So there is no increase in temperature. After reaching the liquid, the temperature will raise up to reach the state of a change between liquid and gas. At this stage, after reaching the boiling point, at the boiling point itself, there's no increase in temperature, as all of the temperature is used in converting liquid into gas. After that, when all of the matter became a gas, the temperature will increase again. So guys, returning back to the graph, we have different areas on the slope to show different transition between state of matter. From A to B is the increasing of temperature of solid to reach the melting point. Say, we have a piece of ice. This piece of ice exists at a degree of -10 degrees. So I will add heat to increase the temperature. Increasing the temperature will make the temperature change from -10 to 0. This slope from A to B represents the increase of temperature. To reach the melting point, which is 0, at 0, there is no increase in the water temperature, as all of the heat added is used in changing all of ice into liquid. After that, we reach C, point C. At C, all of ice changed into liquid. So the temperature will increase again, giving me a rising slope to reach the boiling point. At boiling point, all of heat added will be used in changing the state of matter from liquid to gas. After reaching E, the temperature will increase again. So, at a scale from A to B, temperature change, increase. From B to C, no change. From C to D, it change again. From D to E, no change. From G to F, there's a change again. How to find the amount of heat gained by each interval of the slope? First one from A to B. First slope from A to B. Q is measured as MC delta T. As this is change in temperature, there is increase in the temperature of the piece of ice to reach the melting point. From B to C is the melting process. So we are unable to find Q by this rule, Q equal MC delta T. But there is amount of heat added to the water or for the ice to change it from water to liquid. To find it, Q is equal to MHF. What is HF? It's the heat of fusion. What is the heat of fusion? Is the amount of heat required to change 1 kilogram of substance from solid to liquid. So, if I have a mass of 5 kilogram, I'm going to multiply 5 to the amount of heat of fusion, which belongs to water. So, this 5 kilogram, if each 1 kilogram, which represents the heat of fusion, need 1,000 joule, so the 5 kilogram will need 5,000 joule. By the end, the amount of heat added cannot be calculated using the change in temperature, as the change in temperature will be 0. So if you calculated it using the rule Q equal MC delta T, you will find the amount of heat added is equal to 0, which is not logic. From C to D, we have another process of increasing the temperature. So Q equal MC delta T. At D, we reached the boiling point. So from D to C, all of the heat added to water is consumed in the process called evaporation. So again, we need another rule. Doesn't depend on change in temperature, which is mHV. What is HV? It's the heat of vaporization. Amount of heat required to change 1 kilogram of substance from liquid state to gas state. Well done. From E to F, the temperature of the gas increased again, so I'm able to use the normal rule, which is MC delta T. So what is the heat of fusion, guys? Is the amount of energy needed to melt 1 kilogram of the substance. Heat of vaporization is the thermal energy needed to vaporize 1 kilogram of the substance, as we said. What happens during the melting process? Heat energy increases the temperature of the solid, or heat energy breaks the bonds between particles in the solid. Heat energy decreases the temperature of the solid. Heat energy changes the solid directly into gas. The answer is heat energy breaks the end between particles in the solid. A 5-gram sample of water, so it's the mass, is heated from 0 to 100 and then completely vaporized. What energy is required, assuming seawater, the specific heat of water is 4.18, and the heat of vaporization is 2260. So it will move from 0 degree to reach the evaporization, which means the temperature will be greater than 100. So we have two processes. One of them is the changing or reaching the evaporization point, which is 100, then changing all of the liquid into gas. This one can be calculated by Q equal MC delta T. And this part can be calculated by Q equal mHV, heat of vaporization. M is 5 multiplied by C, which is 4.18, and the change in temperature from 0 to 100, which is 100. Revise the unit, guys. Here, specific heat 4 gram, and also the mass 4 gram. So be careful. And also the heat of vaporization in grams. So it's easy to use gram with gram. We don't need to convert. Here, M is 5 multiplied by 2260. So by adding the results of these two operations, we will find that it will be 13,390 amount of heat added. A substance has a heat of fusion HF. How much heat is required to melt 10 gram masses? And he needs Q. Match the unit, gram and gram. So it's easy to multiply them. M, H, fusion. So 10 multiplied by 334. So the answer will be 3340, which is this one. Laws of thermodynamics, guys. We have 4 laws of thermodynamics. 0 law, first law, second law, third law. We will study only 3 of them. 0, first, and second. 0 law of thermodynamics states that if two objects, for example, A and B, are in thermal equilibrium, and another objects like A and C, so A is coming between B and C. So A and B are in thermal equilibrium, while A and C are in thermal equilibrium. So as a result, B and C have a thermal equilibrium. What is the meaning of thermal equilibrium? There is no change in heat. There is no change in heat. The Zero's law of thermodynamics states that if two systems are in thermodynamic equilibrium with a third system, the two original systems are in thermal equilibrium with each other. Basically, if system A is in thermal equilibrium with system B, and also in thermal equilibrium with system C, so system B and C are in thermal equilibrium with each other. You can scan the QR code and watch the video, guys. What is the meaning of heat engine? Heat engine, guys, is a device that can convert thermal energy to mechanical energy, like the car energy, like the boiler, the old trains. They can change the amount of vapor produced heat energy into mechanical energy. The first law of thermodynamics says that energy can be converted from one form to another form. First law of thermodynamics is talking about the conservation of energy. Energy cannot be created or destroyed, but can be transferred from one form to another form. So, energy can be converted from one form to another form with the interaction of heat, work, and internal energy, but it can't be created or destroyed. So we can do work to transfer the amount of energy from one place to another place. The system can lose some heat to the surrounding or gain some heat from the surrounding, but by the end, there is no destroying of energy. Energy cannot be destroyed or even cannot be created from nowhere. You can scan the QR code and watch the video, guys. Example for first law of thermodynamics. We have something called heat engine, as we said before. This heat engine is one of changing the heat, the thermal energy, into kinetic energy or mechanical energy. So we have a hot reservoir. This hot reservoir has the hot matter. So by increasing its temperature, some of this heat will be transferred to the cold reservoir and other will be used for making work. Like exactly what happened in the car engine. Some of the heat produced from the car engine is used in making the movement of the car, and other is dissipated to the surrounding. So not all of the heat amount produced provided for the work done. Some of this heat is used or dissipated in another way to the environment, to the surrounding. So the formula of first law of thermodynamics says that delta U is equal to Q minus W. Delta U is the change in internal energy. Internal energy is the energy of particles, is equal to Q, the amount of heat added, minus the work done. For the previous figure, the amount of heat received by the cold reservoir is equal to the amount of heat added minus work done. Again, the amount of heat received by the cold reservoir is equal to the amount of heat added minus the work done. So entropy, guys, is the measure of randomness or disorder. As we said, guys, before, as the temperature or the heat content increases, by increasing the heat content, the movement of particles increase, and the randomness of this motion also increase. So, by adding more heat, the randomness increases, the disorder increases. So, the entropy, which is measure the randomness or disorder, also increases. So, entropy is a measure of the disorder or randomness in a system. It quantifies how energy is distributed in the system and the degree in which it can be used to work. In thermodynamics, entropy is often associated with the second law, which states that in any natural process, the total entropy of an isolated system will either increase or remain the constant. Again, for any isolated system, the total entropy of particles will only increase or remain constant, as there is no heat going to leave the system. So the disorder will not decrease. Even to be the same, or you will add heat to the system. Adding heat increases the entropy. Making the system isolated with no heat exchange will remain at constant. So, how to measure entropy, guys? Entropy is the amount of heat added by time. It's the measure of this dispersal energy. We have different key points, guys, to judge and control the entropy. What is the meaning of disorder and randomness? Systems naturally tend to move towards a state of higher entropy. Any system, any particles need to be free, need to have a free motion. To have a free motion, so it must have random motion or to move randomly. So, meaning greater disorder. For example, mixing two gases increase entropy because the particles become more randomly distributed. Energy dispersal. Entropy measures that the spreading out of energy within a system. High entropy, high randomness correspond to evenly distributed energy, whereas low entropy state has concentrated energy. More randomness motion, that means the particle is going to move everywhere, so the piece of matter going to have equal distribution of energy in each part of it. But with low entropy, the energy is concentrated in a certain part of the matter. So all of substance are prefer to have high entropy, high randomness, to make equal distribution of energy between particles. Second law of thermodynamics states that the state of entropy, as we said before, the second law of thermodynamics is dealing with entropy. The second law of thermodynamics states that the state of entropy of the entire universe as an isolated system will always increase over time. The randomness will always increase by time. The second law also states that the change in entropy in the universe can never be negative, which means can never decrease. The first image, guys, shows the transferring of cold energy into heat energy, like the refrigerator. This transferring of heat not occurs spontaneously. It must go under work, So I have to do work to make the heat energy transferred from the cold object to the hot object. So the amount of heat transferred is equal to the work. While the hot object or the energy can be transferred from the hot object to the cold one. Some of this heat energy will be dissipated out. So the amount of heat is the work for transferring the heat, and the amount gained by the cold object. In a cyclic process, let's know, guys, what is the meaning of cyclic process? Cyclic process that it has the same starting point and ending point is the same. So the state of the matter at the same point is the same. It has the same temperature, it has the same heat, it has the same entropy, it has the same. It returned it back to the previous properties of thermal energy. So, whatever the change happened during the cycle, by the end, it will reach the same properties. So, in a cycle process, a system absorbs 500 joules of heat and release 200 joules as work. What happens to the rest of the entropy? It is stored as internal energy, temporary internal energy. it's destroyed, it doesn't follow the first law of thermodynamics. Increases the system entropy, decreases the system entropy. It doesn't follow the second law of thermodynamics. It increases the system entropy. We said the system entropy is constant, doesn't change. So the only correct answer is it's stored as internal energy, but we must know that it's temporary energy. So the system has to lose this amount of energy by the end of the cycle. So the answer will be B. Here is a description of the cyclic process. Cyclic process is the system returns to initial states, meaning there is no change in initial energy. The first law of thermodynamics states that delta U equal Q minus W. We said delta U is the change in internal energy, while W is the work done by the system, and Q is the amount of heat absorbed by the system. So, in a cyclic process, delta U is 0 because there is no change in the internal energy. There is no change in the entropy. So, Q equal W. But the work done by the system here is only 200 in the previous problem. And the system absorbed 500 joules, or 300 of joules are lost. This 300 joule of heat not destroyed, but stored as internal energy temporarily. And the system loses it to the surrounding before the system completes its cycle. This energy contributes the internal entropy change during the process, but overall entropy of the system doesn't change. A gas in a piston absorbs 300 joules of heat and does 150 joules of work on the surrounding. What is the change in the internal energy delta U? We said delta U is equal to Q heat amount minus work done. Heat amount is 300 and the work done is 150. So it will be 150 the change in internal energy of the system. Which process best demonstrates the second law of thermodynamics? Boiling water absorbs heat from a flame, heat flowing naturally from a hot coffee to surrounding air, a machine converting all heat energy into work, ice forming in a freezer. So the answer will be boiling water absorbs heat from a flame, as I'm adding heat. So I'm adding heat. But the second one represents the first law of thermodynamics as the heat flowing naturally from hot coffee to the surrounding air. It represents the first law of thermodynamics. Entropy increases in which of the following scenarios? A hot iron is down in the air because the heat is transferred to the air and increase the amount of randomness of the air. Gas compresses into smaller volume. That means that the volume will be attracted to each other, will be near to each other, so it will be attracted to each other. Water freezes into ice. Also, the distance between the particles or molecules will decrease, so the attraction force will increase. A machine runs perfectly. Reversible process, that means there is no change in entropy, a cyclic motion or a cyclic process, so there is no change in the entropy. So the one which provides a change in entropy increases in the entropy. A hot iron cools down in the air. So guys, we end with this session. Study well, and if you have any question, prepare it for the live session, inshallah.